Hi students, in this lecture I am going to discuss problems. Let us see first one. A cylinder of mass 1 kg, radius 1 meter is kept on the edge of a plank of mass 2 kg and length 12 meter, which in turn is kept on a smooth ground. Coefficient of friction between the plank and cylinder is 0.1. The cylinder is given an impulse which imparts it a velocity 7 meter per second but no angular velocity. Find the time after which the cylinder falls off the plank. That means after what time cylinder reaches other end of the plank. Okay, let us see how to start it. Right, first make the diagram given. So it is a cylinder and this is now on a plank. On a plank, given plank length is 12 meter and mass of the cylinder is 1 kg and plank mass 2 kg. It is given velocity 7 meter per second. It is a cylinder and mu value 0.1. So initially only velocity, no angular velocity. Right, let us see how to start. So first focus solving the question with respect to plank. So this is kept on a smooth ground. So between plank and ground, no friction. So here what happens is, if we can solve the question with respect to plank, it becomes more simple. Okay. So with respect to plank means plank will be stationary. Then it is rolling. Okay. So solving the question from plank frame. So it is now solving from plank frame. You can see this is now slipping on the plank. So when this is slipping on the plank, frictional force acts on the cylinder and on the plank. That means now plank is having acceleration. So this frame is now a non-inertial frame. So in that case, we have to include pseudo force. Okay. Now you can see frictional force acting on cylinder. See how much? So since it is now slipping on cylinder, frictional force will be kinetic and that will be left side because friction always opposes relative motion. It is now kinetic and it is equal to kinetic friction is equal to mu mg, mu value 0.1, mass is 10, sorry, mass is given 1 kg, right? It is 1, it is mass is 1 kg. So mass it is 1 kg, mu mg, g value 10. So it is equal to 1 Newton. So 1 Newton force acting on cylinder, that is left side. It is 1 Newton. Coming to on the cylinder, it is now same 1 Newton acts, that is now right side. Okay. That means for the plank, acceleration is now, since mass is 2 kg, acceleration of the plank, that is now 1 by 2 meter per second square. On the plank, friction is right side. Therefore, acceleration is right side. And since we are solving with respect to plank, pseudo force acting on cylinder is left side. It is m into a. Mass is 1 kg. Acceleration is a half. It is pseudo force is 1 by 2. Okay. Now see what we can say with respect to plank. So we have taken pseudo force. Now it is rolling without slipping. So since rolling without slipping, so focus now. First of all, net force. It is 1 and this is a half. So net value 3 by 2 and mass equal to mass equal to 1 kg. Acceleration of a cylinder with respect to plank, it is equal to 3 by 2. That is left side. That is left side. That means its velocity right side, acceleration is left side. So speed keep on decreases. Okay. And because of friction, torque will be, it is a clockwise. Okay. So after some time rolling starts. Until rolling starts, frictional force exists. And once rolling, until rolling starts, frictional force continues. Once rolling starts, there is no friction. Now see after what time rolling starts. So velocity after some time, it is u minus at. This is velocity of center of mass of the cylinder as a function of time. This is equal to velocity equal to r into omega. And r is given 1. Omega is now alpha t. Right? So to get alpha value, focus now torque equation. So torque equal to, torque is only because of frictional force. Okay. So it is equal to F into R and R is 1. This is equal to I into alpha. And I value for cylinder about its own axis M R square by 2, right? Into alpha. See what is alpha value? Alpha equal to 2 radian per second square, right? So now omega equal to alpha t, alpha value 2. So 2t. So here I have taken condition V equal to R omega. Okay. Now simplify this. 3 by 2 and this is 2. 3 by 2 plus 2. 7 by 2. So 7 equal to 7 by 2t. 7 cancels. So t equal to 2 seconds. So when t equal to 2 seconds, that means if you take this is a t equal to 0, velocity is 7 meter per second. When t equal to 2 seconds, rolling starts without slipping. Okay. So up to 2 seconds, friction exists. Okay. After 2 seconds, no friction. Right. Now see, in these 2 seconds, distance moved by cylinder with respect to plank. I am writing displacement of a cylinder with respect to plank. That is equal to ut minus half a t square. A value. See how much we got? A value 3 by 2. Right? 3 by 2. Half a t square. First 2 seconds. T square. 2 square. Then see 2, 2, 2 square gets cancelled. 7 2s 14. 14 minus 3 11. That means with respect to plan, cylinder has moved 11 meter. Okay. Now remaining is only 1 meter and it has to cover that with a constant velocity. See what is now velocity of a cylinder? Velocity of cylinder is now, so take t equal 2 seconds. 2 gets cancelled. 7 minus 3, that is a 4. It is a 4 meter per 4 meter per second, which will be constant. So now with this velocity, it has to cover remaining 1 meter. Suppose time taken is now t dash. It is equal to 1 meter upon 4 meter per second, right? See what is now total time taken? It is equal to t plus t dash. Means 2 plus 1 by 4. That is 2.25 seconds. So question becomes more simple if we are taking with respect to plan. Okay. Let us see next problem. An L-shaped uniform rod of mass 2m and length 2l. So condition given that AB equal to BC. L and L is in equilibrium as shown with a spring fixed between C and the wall so that AB is vertical and BC is horizontal. There is no friction between the hinge and the rod at A. Now see what we have to calculate. Find the tension in the spring. What is the hinge reaction at point A? If the spring is bound, find the angle between AB and the vertical at equilibrium position. Okay, let us see how to solve. So first make the diagram given. It is now fixed. It is fixed here. It is A, and this is should be, and here we are connecting by a string. Right. Now see first question. Find the tension in the spring. So it is a rigid body which is in equilibrium. So we can write first of all net torque. Net torque is 0. Net force is 0. Right. So to find tension, see what we can do. So better we can take here first torque equation. Since net force is 0, net torque will be same about any point. So I'm choosing now about A, because if you take about A, because of hinge reaction, torque becomes 0. And because of this weight mg, because of that also, torque becomes 0. This is mg, and this also mg, and this is now tension T. Okay, right. So we are taking torque equation about A, so that due to hinge reaction and due to this weight mg, torque becomes 0. Now torque is only because of weight of this part of the rod and due to tension. And you can see by this about this axis, because of mg, torque will be clockwise. And because of tension is like this. Because of tension about this axis, torque will be anti-clockwise. So now net torque must be zero. So I'm writing here first of all mg into this distance equal to L by 2. So mg into L by 2. This is a torque due to this weight. That is a balancing torque due to tension. So T into this length equal to, you can see this length. This is equal to L. So L and L gets cancelled. So T equal to mg by 2. Okay. So we got now tension. See next what we have to calculate. What is the hinge reaction at point A? So now we can use net force equal to 0. Suppose a hinge reaction at this point having two components, vertical and horizontal. I am taking that hinge reaction is having two components, vertical and horizontal. You can see mg. These two are downwards. Sum of these two must be balanced by the vertical component of hinge reaction. So this must be equal to 2mg. Okay. Now on this rod, the tension is horizontal. This must be balanced by horizontal component of hinge reaction. So this must be equal to T. So horizontal component of hinge reaction is mg by 2 tension. So now he is asking what is hinge reaction. That means we have to find resultant. So it is now square root of sum of the squares. Right? So it is now, I can take mg outside. Square root of 2 square, it is a 4. Square of half, 1 by 4. 16 plus 1, 17. So root 17 upon 2 mg. That is now hinge reaction. Right? Next, if the string is burnt, find the angle between AB and the vertical at equilibrium position. Let us see how to get it. If you see carefully, before cutting the string, where was center of mass for this rod? Okay. For this vertical part, center of mass at center. For this horizontal part, center of mass at center. For these two parts, center of mass will be at the midpoint of line joining these two. I hope you are getting it. I am making diagram separately. Vertical part and a horizontal part. Length L, length L. Midpoint is now center of mass for vertical part. Midpoint, center of mass for a horizontal part. For these two center of mass will be midpoint of the line joining these two. Okay. That means its distance from here. It will be L by 4. Okay. This is L by 4. And from here, you can see from here, this distance, it is again L by 4. Okay. Now, if you observe the line joining this fixed point and center of mass. See how much angle it makes with vertical. Suppose angle is theta. This total value L by 2 plus L by 4. This is L by 2. Remaining L by 4. Total value is now 3L by 4. And this is L by 4. So tan theta is equal to, it is L by 4 upon 3L by 4. Okay. So it is equal to 1 by 3. Right. Now see what happens if a string is cut. Question is that one, it is in equilibrium. So it will be in equilibrium if center of mass is below the point of suspension. That means now center of mass must be below point of suspension and rod will be like this. Okay. Center of mass must be below point of suspension. We have to make a diagram properly here. This is angle T. So only key point is that center of mass should be below point of suspension. Then only net torque will be zero. Okay. That means this theta must be same. It is equal to tan inverse 1 by 3. So key point, it is in equilibrium. Center of mass must be below point of suspension. If you are knowing that point, it is very simple. Okay. Let us see now next one. See the question given. A uniform rod AB of mass 2 kg is hinged at one end A. The rod is kept in the horizontal position by a massless string tied to point B. Find the reaction of the hinge on end A of the rod at the instant when string is cut. Is asking just after cutting the string, what is the hinge reaction? Okay. Let us see how to start it. So first make the given diagram. So we are having a support. This is A. Now string is cut. So we have to find hinge reaction. So whenever you want to find out hinge reaction, focus now force equation. That means focus now center of mass. Okay. Now we are focusing center of mass. Weight mg downwards. See weight how much is given? It is given 2 kg. It is now if g value is 10, it is 20. 20 down. Suppose hinge reaction, it is vertically up. Okay. Now we can see this center of the rod follows circular path. You can see it follows now circular path. Then these forces are parallel to tangent. Okay. So I'm writing here tangential force 20 minus F. This is now tangential force, which is equal to mass into tangential acceleration. Mass into tangential acceleration is R into alpha. R into alpha. Rod length, it is not mentioned. So take it as L. Then it follows circular path of radius L by 2. R alpha. Okay. Now in this, if we know alpha value, then we can find hinge reaction. Okay. And you have to focus one more thing. Are we having any horizontal component for hinge reaction? So it is just after cutting center of mass having no acceleration. Sorry, center of mass having no velocity. No velocity means no centripetal acceleration, right? Because centripetal acceleration is v square by r. Just after cutting, velocity is zero. So no centripetal acceleration. That's why there is no horizontal component of hinge reaction. It is only along vertical. Right. To find alpha, I am taking a torque equation about the support. Okay, so about hinge torque equation. 20 into distance is L by 2. So 20 into L by 2. That is now torque. Torque equal to I into alpha. And I value M L square by 3. Rotation about one end of the rod. So 20 into L by 2. This is a torque. That is equal to I into I value M L square by 3. Right? Into alpha. Now simplify. 1 L gets cancelled. Next. 2 here 10 times and this 2 here 5, right? So what else left here? Alpha equal to 15 by L. 15 by L radian per second square. Okay. Substitute that in this one. So 2 and 2 gets cancelled. So 20 minus F is equal to L into alpha value 15 by L. That means F equal to 5 Newton. Okay. So it is very simple and direct, right?